Hello students, today we saw about VI programming techniques. VI nothing but virtual instrumentation. LabVIEW programming are called as virtual instrumentation. LabVIEW is one of the program used for virtual instrumentation and human machine interfacing purposes. In this LabVIEW we have two panels. One is front panel, another one is block diagram. Front panel work as front end and block diagram you run as back end of the program. In front panel we have controllers that is used for inputs and indicators that is used for outputs. In block diagram we have a program circuits, okay, and also that circuits will be wired together in block diagram only, okay. This is the example of front panel. In this we have a controller. This is the one of the controller and this is one of the indicators. The controller help to start the temperature checking, and the indicator shows the temperature by means of thermometer sensor. And another one area having waveform graph. This is used to analyze the temperature history. Next, this is the block diagram. In this block diagram only, we have to use a circuits diagram with wire connections. So, the entire working of the program is connected here only. The total inputs and outputs are clearly drawn by using various tools in block diagram. This is example of one circuits. So in this the temperature can be analysis by means of thermometer, and also same temperature will be sent to temperature history. In thermometer we have a terminal display and temperature graph, that means temperature history. We have a waveform graph that shows the output of analysis in front panel only. Next one, control and function palette. Control palette used in front panel and functional palette used on drawing window. In control panel we have here various tools. This is the example of tools that is used to input and output of controller and indicators. You in front end panel. In drawing window we have a functional palette. This is used various functions like easy related and robotics related and mechanical related, where we have a various graphical and floating different types of tools available on functional palette. This is used to draw a circuit in drawing window. Next one, tool palette. The tool palette, also named as floating palette, it is used to operate and modify front panel and block diagram objects. These are the some examples of tool palettes. First one is operating tool, positioning and resizing tool, labeling tool, wiring tool, shortcut menu tool, automatic selection tool, scrolling tool, breakpoint tool, probe tool, color copying tool and coloring tool. This tool palette helped on both front and diagram panel. Next one, status toolbar. This status toolbar also worked on both front and block diagram. This is help to show the status, and also it is help to execution purpose. These are the some of the examples. First one is run button, continuous run button, abort execution, pause and continuous button, text settings, align objects, distribute objects, and reordering. And also additional button on diagram toolbar that have execution, highlighting button, steps into button, steps over button, steps out button. Open and run a virtual instrumentation. So when you open a virtual program, we need to get a signal generation that is called input from raw data. When you, for example, in first diagram we got a temperature input. No, the temperature signal generation we need to get for programming purpose. And next, that is we need to process on virtual instrumentations. If you have any doubt means go for help and find examples on the programs. Next, browse according to task, analyzing and processing signal, signal processing, and next signal generation and processing VA. This is creating a virtual instrumentation. This is the front panel window. This is the one of the example. This is front panel window. This is one separate panel. This is one another one separate panel. In this we have input the sections, that is A and B are inputs. This is the execution panel, that is we have to A plus B addition output, that means indicator, A minus B indicator. We have two inputs and two indicators in front panel. This is the block diagram window. We have A input no. In front panel we have A input no. That is showed in the block diagram, and also B that is also shown in block diagram. We need to wire. We only need to wire according to our operations. That our operation is, that is A plus B. That means we need to go for addition. So we need to get it from functional tool. Okay, we need to get it from functional tool, and also we need to wire from raw data from A and B. This is the tool we need to execute addition, that is sent to indicator terminal A plus B. That A plus B indicator will be shown in this channel. And also we need to another one output no, that subtract. This is also tool we need to extract from functional toolbar. Okay. And also we need to wire it from input A and input B. This is the subtraction. This subtraction execute part output will be connected to A minus B indicator terminal. Sorry. Okay. Next one. If you give input on A and B means this indicator shows the A plus B. This indicator shows the A minus B. This is the one of the example of virtual instrumentation. This is the steps we need to follow. Creating VI block diagram. After creating front panel control and indicator, switch to block diagram. Control E, this is the shortcut. Move front panel object to desired location using the positioning and resizing and selecting tool. Place function on diagram. Wire approximate terminal together to complete the diagram. This is the steps I told in before slide. Okay, this is the example of VI generation in LabVIEW software. Okay, so LabVIEW software is the base for so many purpose. So it is the used for virtualize the total one program, circuit program will be easily virtualized by using this program. Then only we got output. It is used for practicing the software itself. Okay.